Okay. Welcome, Computer Science UA, to another tutorial. What we're going to do today is we're going to have a look at doing some object orientation. Now, that being said, you would have seen that tomorrow's lecture is actually on object orientation. Now, because things are a bit weird in terms of the structure of the lectures, I'm still trying to adjust the course to be a bit different. It used to be different a long time ago, before COVID. And then with COVID, just before COVID happened, we changed the lecture timetable. And things don't work out exactly as they were before. So some concepts I have to do sort of half and half, and that's what I'm going to do today. It's because I need to teach you something in code, I still need to teach you the theory behind it as well. So we're going to look at some things now in code, which we'll only look at the theory tomorrow. And that's perfectly fine. Nothing to worry about, because the things I'm going to show you is sort of what you know already in C++, but just applying it now to the Java context. So far, what we've been doing is we've just been sort of toying around with one class and just dealing everything inside of this main. And we still have to talk about the static and what does it mean. And so far, everything we've done inside of main. So main is the entry point of our application, and that's where the starting point is for any application that you write. You have some sort of entry point being the main method. Specifically in Java, only a single main method available, and that's the one we're going to use. So what I want to do today is start working on an ongoing concept or ongoing set of tutorials where we're going to build an application from scratch. And what it's going to sort of mirror is what you're going to get in the practicals. In the practicals, you'll get given a story, you get given tasks to do. So you'll see in practical 1, for example, you are given the task of starting to develop a system to manage something. And as we go on, as you learn new concepts, what we're going to do is we're going to take that knowledge which you built up in that first practical and extend it. We're going to add on to it. So the same thing I'm going to do now with the tutorials. In order to do that, I need to give you a story, just like there's a story in the practicals. I need to give you a story for the tutorials. Now, the story which I'm going to give you is going to be a little bit boring, but sometimes boring is good because it's easier to explain things than trying to explain something very far-fetched and out there. So what we're going to do is we're going to start sort of identifying a problem statement. This is how you would do software development when you eventually go out into the real world. You get told by your client or your customer that they want to do something. They have a business idea, they have a business model already in place, and they want you to implement some sort of software. So there's some sort of problem definition. They want to do something, and now you need to model that problem in code, in software. So that's what we're going to do. We're going to start looking at that problem statement and start building up the classes. There's going to be a lot of changes. Software isn't static. It's not just, I write it once, I forget about it, everything works fine, I'm happy with life, carry on. When you start out, you only know a little bit about the system, and as time progresses, there might be more requirements, there might be changing requirements, and you'll have to adapt. So what we're going to do is we're going to sort of get rid of this class. We don't need Wild West anymore. That's the tutorial class that we were using. And instead what we're going to do is we're going to replace this with main. So obviously we need to create these classes. So in my project folder, I'm going to get rid of main, Wild West. I'm going to put main there. And obviously this is just the same file. I just renamed it now. So we're going to clean this up. And what we're going to write here in comments is just our problem definition and then also what we're actually going to do. So we're going to get rid of all of this other methods that we don't need right now. And for now, this is just going to be empty. So what is our problem definition? Our problem definition is we're going to write software to manage students registering at a university. Sound familiar? No? Didn't you register at a university for a degree? When you register, what happens? You register for a degree for a specific year, and you have a number of modules that you need to do. So that's what we're going to model, because you have experience with it. That's the reason why I choose this as a tutorial topic. You have experience with it. But now, instead of being the user of the system, the person who needs to use the system, you are going to be the developer of said system. Now, we're not going to develop something that's going to be used on the scale of something like UJ. We're just going to do a small prototype system, because obviously doing something large scale, you need a lot of testing. You probably need a team of developers to do it. And it's not just for a small set of users, it's for a larger audience. There's different types of users, etc. So we're just going to look at this as an example system. We're not obviously going to do all the things in it. We are going to do a good graphical user interface for it, but it's going to be a very simplified user interface for very simplified tasks. So with that problem definition, we need to have students that register for degrees, and then those degrees have a number of modules associated with them in a specific year. We can work around that if we need be, but that's sort of what we're going to have a look at right now. As we progress further, there might be more things we need to include in the system. But as I go through this, I'm going to ask you questions about what data we need to store, how are we going to store it, how are we going to manage it. And because we're designing the system, you're going to be part of that process of designing the system. And we'll talk about, if I ask you something and you give me an answer, we'll talk about is that the right approach or is it the wrong approach. Certain things is straightforward, certain things won't be, as you'll see in just a few minutes. So what we're going to do here in main is we're going to sort of lay out in comments here what we need to start developing, what we're going to start working with. So first thing we need to talk about is what do we need to store information about? We need to store information about students. Okay, we need to store information about students. What else do we need to store information about? Your degree. So what degree you're going to be studying for. And with that, we have, it'll be students, degrees, modules. What else? What else would be important in a system like this? I'm asking you now. What else would be important in a system like this? Say louder. Okay, so information about those specific things we'll put in those classes when we get there. I'm talking about the bigger picture now. What other things do we need to store information about? So duration would be something part of the degree. Say again? That's also, again, part of the degree. I'm talking now about classes more than information inside of a class. So a timetable, so you need some sort of way to indicate a timetable. Now that's a very difficult topic, something that's very interesting to do. We're not going to do that. So I'm not saying it's not a good idea, but in terms of trying to teach you something, that is something complex. So great idea, not something I'm going to do right now. Maybe we'll look at it in the future. So just keep that in mind. Timetable, something we might look at in the future. Faculty. So with a university, you usually have a number of faculties. Inside each faculty, you have a number of departments. And each department, you have a number of modules that belong to that department. So there's a whole hierarchy. And again, I can put all of those things in. Good suggestions. We're not going to design the system that in depth. So other things you could do is things like the faculty. They could be departments. So faculty, departments, all of those things. What was up on timetable? So all of those things are important, but we're going to not do it right now. So this is something that we'll come to a bit later. One other thing which we might need that's going to be important is the people teaching the actual modules. We need information about them. So we're going to stick with this right now, those sort of 4 classes there. There might be more a bit later. As you can see, we've got the faculty department timetable, all of those things as well. But when we get there, we'll add those specific things. So we now need to get out of just working with a single class and try and work with more than one. We're going to take a small step now and just work with students and try to see how we do things in Java. After we cover the theory in tomorrow's lecture, then on Friday, we'll jump back in and do more classes. And what I want you to pay attention to is how long it takes me to type out these things. That's one of the things that you're experiencing in your practical 1. You have to type out everything. And that's on purpose. I spoke about IDEs, and we are going to use one eventually, just not yet. So the reason why we're doing that is to show you how things are done, why they're done in that way. When an IDE does it automatically for you, you don't know why. I'm trying to teach you why before you use an IDE. Okay, so we got our main method. It doesn't do anything special. And what we want to do is we're going to create a student class. So if you were in C++, you would go create a header file, student.h, a CPP file, student.cpp, and then put your code in there. In Java, we only have one file to worry about, and that's exactly what we're going to do. Only worry about one file, and that one file is going to be called student.java. So again, make sure you don't have that .txt at the end. We want to make this a Java file, a source code file. And then we have to remember what is our convention. Our convention states, or the compiler even states, that the public outermost class has to be the same name as the file. So public class student, and with that, we have a student class. We don't need to put a main method here because the main method is in our class called main. That's the only responsibility of main at this point in time, to hold the main method. Everything else should only be what the class does and nothing else. Question? So the question is, are we going to have a Java file for each class? And the answer right now, though it might change in the future, but right now, each public class, and that's important, each public class is going to have its own file. So if we look at our situation right now, we're going to have student, degree. So here I actually said students, degrees, modules, etc. The name of your class should just be the noun without the plural. If you're doing other things with handling databases, you might put S's at the end. It depends on what you're trying to do. But for our purposes right now, we're just going to put it as student, not students. Students are usually a collection. So for each of these different classes, we're going to have separate files. So there'll be a student.java, degree.java, module.java, interpret.java, so on and so forth. So now for the student class, we want to use it. We want to be able to do something with it. So right now, it's currently empty, nothing in there. Let's see what we can actually do with the student. So in our main, we're going to say, okay, this is what we want to do. This is our plan. So I'm going to put the plan somewhere here as a comment. And then inside of my main, what I want to do is create an instance of that student. Question? So you're asking about one file for multiple classes. So the question is, will there be a point in time where we'll use one class file, so one .java file with multiple classes inside of it? Yes, in the future, but there'll be a reason for that, and we'll talk about the reason when we get there. Advanced Object Orientation Part 2, I think. That's when we'll talk about that. So still a couple of weeks away. So what I want to do now is I want to create an instance of my class. So far, we've been doing everything as static, and static basically means it belongs to a class, not to an instance. Since we're working with main, and main, we don't really care what's inside of it. We're not going to create instances of main. We want to create instances of our classes. We sort of saw how to do this when we looked at working with scanner. So Java util scanner back when we did the hello world. And what we're going to do is we're going to create a variable. So you obviously need to declare the type of that variable, the name of that variable, and then new, because everything in Java has to use the new keyword. There's no option to leave the new keyword out when you're creating an instance of an object or instance of a class. And here we're going to create that class and just leave it like that. So let's see what actually happens. Let's see what happens. So I have my code. I changed my batch file. Hopefully it's correct. We only find out when we actually run our code. I'm going to get rid of that. Okay, so I'm going to run my build.bat. So it's setting the path, it's compiling. Compilation's done. Remember, we put a pause after compilation. It then did javadoc. Okay, it did some javadoc stuff, and then it ran, and it finished. Now, notice what I did. I didn't specify compile student.java. I didn't specify that anyway. I didn't say import Java, import student from anywhere. There's no using namespace, no calling other things. So at the moment, we didn't call any of those things, but if I go and look inside my bin folder, and this wildwest class was the old class, so let's just get rid of that. If you notice here, there's two files. Main.class, that's my main class being compiled, but student.class was compiled as well. So something interesting happens with Java compilation. If you look at main, in order to compile main, what do we need to do? We need to go through main and see what classes it uses. And right there, on line 19, we are using student. And how do we use student? Okay, Java compiler goes and looks for student. It sees the student class, says, okay, I know what student is. Let me compile it. If it compiles successfully, then main can compile successfully because it has all the different components and everything works out. So this is a very important concept when you work with Java files and Java compilation. This is how your batch file is going to work at the end of the day, is you only need to compile one class, and that is your main. Because your main is going to use another class, and that class is going to use another class, and that class is going to use another class, in order for everything to work correctly, main will ask for compilation of the next class. That class might ask for the compilation of the next class. So class A might ask for class B might ask for class C. Class C gets compiled, B can compile, A can compile, and then main can compile. So that's what's going to happen. At the moment, we are not using packages. We'll talk about packages theory tomorrow. But packages are just a way to group code together if we don't specify a package. We never specified any packages here. This is just an empty class. And we never specified a package here. There's nothing there. We are in something called the default package. So it's provided by default by the language. There's no need to import anything from the default package. It's available to anything inside of the default package. First question is back, yeah? So the question was, how does the main class know about the student class? So at the moment, everything is in the default package. Everything in the default package knows about each other. Because we specified in our compilation this argument here of source path, we're telling the compiler, if you see something you don't know about, here is the place where you can look for source code. So main doesn't explicitly know where student.java is, but we told the compiler, go look for source files here. In addition, we told it, if you're looking for class files and they're not in the source path, they might be in the library folder, which we haven't added to this specific batch file yet, but that's another place where classes can exist in a library file. So you did it in C++, it was DLLs. You could add functionality in DLLs. You had to tell the program where the DLL was, or you had to add it in the same folder or something like that. We can add that functionality here as well. When we get to that point, we'll put it in. But at the moment, the compiler, we're telling it where to look for source files. That's how it knows where to find the source code of student.java. We didn't explicitly say this is where it is, but that's where the compiler will look for source code files, specifically student.java. Say again? Okay, so the question was about IDEs. When we get to IDEs, I'll answer that question. Right now, don't worry about it. Okay, so let's go back to what we did here. What did we do? We created an instance of a student. But if I look at my class here, did I specify a constructor? No. But I used the constructor. So that is calling the constructor of the student class. So just like C++ had some defaults available for certain things, Java also provides defaults for certain things. If there is no constructor specified, you get a default, no arguments, so you can't pass arguments to it, no parameters, constructor. That's what we have. There are extra things specified as well. You might have seen it in the Java documentation. There were some other methods there specified which we didn't write any code for, but they were there. We'll talk about why that is in the theory lecture tomorrow. So right now we have the student. What can we do with it? So if we do something like system out print line, then what it will happen is some things happen automatically in this case here. We're passing a reference to function that expects a string. So what happens is it will get converted to a string by the print line statement. There's a function that will call another function, so it's sort of like delegation, and that function will call a string version of your reference. And there is, by default, provided by Java, a way to represent an object as a string. What does it look like? Well, let's compile again and run the code and find out. So again, compile, javadoc will happen again. And then when you run, there you can see there is something specified there. It's the name of the class, so you can see there it's student, @ symbol, and then a set of hexadecimal characters. Hexadecimal, you should remember what that is. That is numbers from 0 to 9, A, B, C, D, E, F. So any of those characters represent a hexadecimal string, hexadecimal number, and that's what's represented there. It's a hash value of the string. That's by default. We can change this later. We can change it to something else, but we'll talk about that when we get to the theory. Now, that doesn't give me useful information because we might want to store specific information for our student class. So what we need to do here is we need to start creating instance variables for our student class. We need to start adding data to our class. So when we create an object, we got some data that can go along with it. Now, as I said previously, when we looked at the shipping box class in the lecture yesterday, practical lecture, we have to qualify each of the things we do in Java with visibility modifiers and any other modifiers. So here, because we're going to do something called information hiding. Do you remember information hiding from object orientation concepts from 1B? Do you remember? What is information hiding? More things that should go in a class test or your semester test. So information hiding is the concept of hiding information unless it's explicitly available through access commutator methods. So everything is hidden by default, and then you provide access to those things through other methods. So we'll talk about that again tomorrow when we get through the theory, but by default, we're going to make everything private and make it available some other way. So what do I want to store in this class? So what I'm going to do now is I'm going to store some information. So let's actually not do that. What information should we store about students? What's going to be important to store about students? Student number. Why do I need a student number? Why do I need a student number? It's a unique identifier. So those of you who are doing informatics 2A, you're learning about databases and you're learning about unique identifiers. Those of you who are not, unique identifiers is a way to identify something uniquely. Can I use surname as a unique identifier? Now you might say, no, I don't know anyone else with my surname. It should be fine. There's a lot of you, a lot of students. And the likelihood of having someone else with the same surname is actually quite high. I've had some years where the students have, 4 students have the same surname. And out of that 4 students, they have the same first name. 2 of them have the same first name. So you can't rely on something like a surname and or a first name. Other problems occur with something like surnames. People get married and it changes. Then is that a new person or is that the same person with different information? So if you use something like a student number, doesn't matter what happens to the surname, doesn't matter what happens to the first name, it's a unique identifier for that person. So we're going to store a student number. What else? So I said we're probably going to store a first name. We're probably going to store a last name. You might have some people that have middle names. What else? What's important for this type of system? Qualification. Not something that we might want to store in this class, because the whole point of it is to register people for that. That might be stored somewhere else. So we're not going to store qualifications in this class at the moment. Might do it somewhere else. Anyone else? ID number. So that's something else you could store. Not everyone has an ID number. Some people have passport numbers or some other identifier. We can store the information. For our purposes, we're not going to worry too much about that. Contact details, address, all those important things for our purposes, because I don't want to type out 20 different addresses every time I create a student. I'm not going to do that right now, but that's something that's going to be important for a real life system. So some of the things, as I said, we're not going to do every single thing, but some things are going to be important. Some things which are important, we're not going to do because we're limited on amount of time. Would I store hair color as an attribute in this class? Isn't it important? I want to know how many people have black hair for this degree. How many people have white hair for this degree? How many people have red hair for this degree? Isn't that important? Oh wait, someone has purple hair. No, it's not important. It might be important for something like a hair salon system. You want to know what your client's hair color was before they came to see you and after you did your business. But for our system, those types of information is not important. So that's part of your problem definition, identifying what's important and what's not important. So gender, the politically correct term is gender. And speaking about politically correct, what data type should gender be? Very controversial topic, especially now in this day and age. What data type should the gender be? When I first started lecturing a long time ago, the data type was a Boolean, and it was no problem. Nowadays, if it's a Boolean, it's a problem. So what data type should it be? Some people will say Boolean, some people will say number. Okay, which number is first? Which gender is first in that list? Which gender is last? Now that's another topic which I'm not going to delve into. I can see people raising their hands, ready for answers. It's something I'm not going to discuss in detail. Why? Because I'm here to teach you computer science. I'm not here to teach you politics. Even though it's an important concept and something we do touch on in later years, especially when you get to honors, there's a compulsory module that you have to do in honors called Ethical and Legal Aspects of IT. And we discuss this kind of topic in detail. So genders is going to be an important thing in a system. It's going to be something that needs to be politically correct in this day and age. But for now, we'll put it in and we'll leave it ambiguous as a type until I get there. We might store some information for it, but just note this is an example, and as examples go, it doesn't represent real life 100%. So results, again, I wouldn't really store that in the student class itself. It might be part of the student information, but it might be stored in some other form somewhere else. So we don't want to fill this class with as much information as possible. We want to try and keep it as basic and then have relationships with other classes we can fall back onto to get that data. Again, it's sort of half the picture because I am biased. I am in the Academy of Computer Science and Software Engineering. I know informatics and computer science usually go hand in hand. Some of you here are doing computer science and a different major, stats or maths or something like that. Anyone here that's doing that? Yeah, a few of you. Usually there's a few of you that do that. Usually my comment to those people is why? And then I know computer science, I know informatics. I know maths. I didn't study maths in that way, but you are. Now, you are going to see half the picture because those who are doing informatics know about building systems where you're trying to separate out the information from one set of entities to another set of entities. You don't want to cram everything together. So I want to teach you some of those concepts, but obviously I can't teach you everything. And I do rely on that information. I'll talk about it a little bit, but I don't expect you to know informatics. It's a good idea to look at it in your own time, especially if you're doing IT in general. It's always a good idea to get a whole picture instead of just half of it. But if you need more information, those of you who are doing it only computer science as a major and not informatics, you can always ask me about it a bit later. All right, so let's try and implement some of these things now in actual class. Like I said, we're going to have to do things as private. And then we need to start putting data types. So what data type should a student number be? What data type should a student number be? An integer. Anyone else? A string. Now, why would you choose string over integer? Or what? Excuse me. Why would you choose integer over string? So if we look at identifiers in general, if we look at South African ID numbers, South African ID numbers are that, numbers. It's the date. It's usually the next set of numbers indicate if you're born. I have to be careful with my wording again here. Born either male or female. and then the last set of numbers is some other checksums and stuff for the earlier numbers. But it's all numbers. So that's South Africa. If you look at other countries, they have letters in their unique identifiers for citizens of that country. Now, at UJ, since its founding, it's only been numbers. A couple of things changed over the years. It used to be the first 4 digits was the year you registered. So it used to be 2010, another 5 digits. But then they ran out of numbers. So then it changed to swapping out the 20 to just be a 2 and then the rest of the year. So that's why some of you might have 2 and then whatever comes in afterwards instead of 20 and then the other digits, and then the rest of it was for a unique identifier. So in terms of a student number, usually a student number, integers make sense, it works. However, it might become a time when they say, okay, we don't want to just store integers, we might want to store letters as well, and that letter might mean something special. It might mean in the future that you belong to APK campus first, other campuses later. It might mean that you belong to a certain faculty first, whatever the case may be. If we store it as integers and later had to change it to strings, it's not so much of a big deal. But if we started with strings and had to change to integers, that would be a problem. So rather just stick with something that works really well, and that would be strings. You could do either one. And again, what I'm trying to say here is it depends on your use case. There's no one answer. And that's what you're going to experience in software development. There is no one answer. There's an option, another option, and you need to use what you understand of how to do things to make the right choice. Sometimes you don't make the right choice, and you have to go change it later. So that's what we'll might see when we start developing the system. So for now, let's start off with integers, and let's see if that's going to be a problem. The reason why I'm doing this as well is because if you look at the next three, they're all strings. So I want to have something a little bit different here. Question? Okay, so 2 questions. Are student numbers randomized? And could we use a long instead of an integer? So I'll answer the long and integer question first. You could use long. There's no reason not to, except that longs can store a lot bigger numbers, and you don't really need to. So it is possible. And then another question is student numbers randomized? And the answer is no. Whoever registers first gets 0000001. Next, 00002. That's how it goes. So interesting little fact. When I registered a very long time ago to be a student, I actually got 2 student numbers. Because they sent out the first number, they made a mistake, they had to redo the system, and then I got another student number. So it's going to be in a certain order, but yeah, it's always in a specified order. So if your student number, the last 6 digits or 5 digits, if that's a very high number, you registered later than someone who has a lower number. Is it possible to use an array of characters instead of a string? Yes. Why would you want to? Space-wise, it's not going to be so important. When we talk about strings next week, we'll learn about why. Okay, so the next few things, first name, middle name, last name. So actually want to swap those around. So the next few are all going to be strings. So here, our interesting thing here, I'm going to put this as character. Hopefully 26 plus the numbers plus all the punctuation marks is enough. We'll see. All right, so we have some information now, and we want to be able to use it. So what we need to do, we need to define a constructor that can take in arguments and assign values to that. If I leave it as is right now, so I didn't change my main still calls the default constructor, still prints out that information. If I run this again, it works perfectly fine, because I said we have this information available, it's just not populated now. Default constructor doesn't give anything that it can populate. Okay, so it seems that I am out of time. So we'll get to carry on this on Friday. If there are any questions, I'll be here in the front for a few minutes before I leave. Otherwise, I'll see you in tomorrow's lecture.